Next, we have to solve the equation 2 to the power of 2x times 27 to the power of 3 minus x equals 1 over 9. Now, when I look at this question, I see 3 bases that can be converted into the same base. So I think we should do that. Now, 9 to the power of 2x, 9 can be converted into a base 3 with a power of 2, 3 squared. And then we put the 2x right there. And for sake of simplicity, I'm going to take each of these terms one at a time. So I'm going to write out this just the way it was in the question. Now 3 squared to the power of 2x. The laws of exponents tells us that if we have a situation where an exponent is being multiplied to an exponent, we can go ahead and multiply the two exponents together. Meaning that this would become 2 times 2x is 4x, so then we'd have 3 to the power of 4x. Now next we're going to try and convert 27 into a power of 3, or into a base 3. 27 is 3 cubed, and we write this the way it was. And again, for sake of simplicity, I'm going to keep the 1 over 9 the way it is for now. Now 3 cubed multiplied by this would be 9 minus 3x equals 1 over 9. Now we've successfully converted the first two terms into base 3's. Now we're going to attempt so with 1 over 9. Now can 1 over 9 be converted into a base 3? Well, let's try to first convert it into a base 9, which would give us 9 to the power of minus 1. Now from here, it's a lot easier to convert the 9 into a base 3. So then we'd have, instead of this, we'd have 3 squared, and then to the power of minus 1. And then once again, we can go ahead and multiply these two exponents together, which would give us minus 1 times 2 is minus 2. Then we'd have that. Now I'm going to use another law of exponents, saying that when I multiply two bases of the same base, or two numbers of the same base, I can go ahead and add these exponents together, which means that we're going to be left with a single base 3 here, and we're going to add 4x with 9 minus 3x. Add 9 minus 3x. And this side remains the same, 3 to the power of minus 2. Now since we have two bases on different sides of an equation, we can go ahead and remove the bases, and the exponents should remain equal to each other, meaning that we can go ahead and get rid of these 3's. And then we'd have 4x minus 9 plus 9 minus 3x equals minus 2. And here it's looking a lot more straightforward. We can just simplify this down. 4x minus 3x is x equals, move the plus 9 to the other side, we'd have minus 11, and x equals minus 11 is our final answer. Lastly, we're going to solve for x in this complex fraction. Now, as you can see, there are two sides to this very complicated fraction, so I'm going to indeed break them up into smaller fractions. So we're going to deal with this section of the fraction first. X over x plus 6 plus 1. Now, in order to commence this operation, we have to change this plus 1 into a fraction with the denominator of x plus 6. So it's going to be something plus something to the fraction of x plus 6. Now, this is in fact, 1 is in fact the same as 1 over 1. Therefore, when I multiply the bottom one by x plus 6 to give me this, I should also multiply the top one by x plus 6. Because that would also be equal to 1. This fraction by itself is equal to 1. So now I can go ahead and add these two fractions together. X plus x is 2x. And the plus 6 remain where it is. Now we're going to work with the bottom side. So let's go ahead and write this out. Got 27 over x squared minus 36 plus 1. Now once again, in order to add this plus 1 into the fraction, I'm going to convert this plus 1 into a fraction with the denominator of x squared minus 36. So I know the bottom side has to be x squared minus 36. Therefore, the top side should also be x squared minus 36. And now I can just go ahead and add them together. Got plus squared minus 36, all over the same denominator of x squared minus 36. Now we simplify this down to give us x squared. 27 minus 36 is minus 9. And of course over x squared minus 36. Now you're going to notice that x squared minus 9 is a special thing we call the difference of two squares, meaning that we can factor this immediately into x plus 3 and x minus 3. At the same time, x squared minus 36 is also a difference of two squares. We can factor it down rather, into x plus 6, x minus 6. So far we've managed to simplify our complex fraction into this right here, where we've got 2x plus 6 over x plus 6 on one side, and then these factors on the other side. Now to divide two fractions, a simple way is to turn this into multiplication. And we're going to multiply by the inverse of this side, which means that we're going to flip the bottom and top numbers. Therefore, these two would become 6, and these bottom ones would become 3. Now, because we're multiplying by factors, it's very simple. We just join the numerators and the denominator of each fraction together. So you'd have 2x plus 6 multiplied by x plus 6 multiplied by x minus 6 over the denominator, which is x plus 6 multiplied by x plus 3 and multiplied by x minus 3. Now I noticed that there's one factor in here which is not prime just yet. It is not completely factorized, and that would be the 2x plus 6. Now this is because I can take 2 out of 2x and I can take 2 out of 6. So let's go ahead and do that. Take the factor of 2 out. I'm going to have 2 bracket x plus 3. Now each of these factors should be prime at this point. We see that there are factors on the numerator and denominator that are identical to each other, so we can go ahead and cancel those ones out. For example, x plus 3 occurs at top and bottom, so we cancel those out. And likewise for x plus 6, which means that we're left with these remaining factors, the 2, x minus 6, and x minus 3. So let's go ahead and write them out. And now we can go ahead and distribute the 2 into each of these terms on the numerator. And 2 multiplied by x is 2x, and 2 multiplied by minus 6 is minus 12. And the x minus 3 remains the same. We've now arrived at our final answer of 2x minus 12 over x minus 3. So hopefully you found my help for today's questions useful, and I'd love to see you next time.